in the span of just 4 inches, less than the width of a human hand. The temperature on the lunar surface drops by a staggering 60 degrees Celsius. Imagine standing on ground as hot as a desert summer, while just beneath your boots, the soil is frozen in a deep chill. How could a world we have gazed at for thousands of years hide such a radical secret right under its skin? What if the moon is not the dead? Gray wasteland our textbooks described, but the literal gateway to the stars. While the rest of the world followed its daily routine, India's Chandrayaan-3 mission was writing a chapter that left the global scientific community in total shock. They did not choose the easy path. They went straight for the forbidden zone, the mysterious lunar South Pole. This is a land of eternal shadows and craters so deep they feel like bottomless pits, where the cold is more intense than anywhere on Earth. But India did the impossible, touching ground where no wheel had ever turned before. What they found hidden in that fine, ash-like dust is more than just rocks. It is a discovery that could pivot the future of our species by 180 degrees. The success of Chandrayaan-3 was never a matter of luck or a simple roll of the dice. It was the hard-won result of years of grueling labor, of learning from painful mistakes, and of refusing to back down when things turned ugly in previous attempts. The entire world was glued to their screens, holding their breath during those famous minutes of terror, where a single tiny glitch could have sent years of sacrifice straight into the trash. But when the Vikram module finally settled softly into the lunar dust, the entire landscape of space exploration shifted forever. While some viewed this achievement as a mere display of national pride or a political power play, that was barely the tip of the iceberg. The true magic began just minutes later when the ramp opened and the small Pragyan rover rolled for the very first time onto virgin territory. This mission quickly transformed into a literal gold mine for modern science. We are no longer just confirming theories that astronomers have discussed in offices for decades. We are uncovering surprises about the true face of the moon that absolutely no one saw coming. For the first time in history, we possess fresh, ground-level data from a zone that has guarded its secrets for billions of years. This expedition is revealing that our lunar neighbor is far more complex and mysterious than we ever dared to imagine. Once the Pragyan rover rolled down that ramp, it did not just wander around for a souvenir photo. It went to work like a pioneer digging for buried treasure. The first major bombshell the mission dropped was the absolute confirmation of sulfur on the lunar surface. You might wonder why a simple element matters so much. For years, sulfur was a piece of the puzzle that scientists could never quite grasp. From high in orbit, satellites have a hard time detecting it because its signals are faint and easily confused. But Pragyan carried a sophisticated tool called LIBS, a laser that fires intense bursts at rocks to turn a tiny bit of matter into glowing plasma. It was as if the rover was interrogating the lunar stones, forcing them to confess their secrets. When the data reached Earth, the team at ISRO could hardly believe it. The sulfur was right there. This is not just a footnote for geologists. It changes the entire narrative of how the moon was formed. Finding sulfur is like finding ash in a place you were told never saw a fire. It tells a story of an ancient, active moon with fiery guts. And for those who dream of one day living there, sulfur is a massive win. It can be used to build high-tech batteries, create lunar concrete without needing water, or even act as fertilizer for greenhouses. It is like finding the raw materials for a city in the most remote part of our solar system. The chemical celebration did not stop with sulfur. As Pragyan's laser continued its work, the guest list of elements grew even more diverse. Suddenly, signals for aluminum, iron, calcium, and titanium began to appear. Imagine the scene. We are essentially standing in front of a giant cosmic hardware store. Aluminum and titanium are the lightweight, ultra-strong metals we use back home to build airplanes and spacecraft. Finding them ready to be processed on the moon is like arriving at a deserted island and discovering bricks and steel rods already waiting for you to build a house. Iron is equally vital. Where there is iron, there is the potential to manufacture tools and heavy structures right on site. This discovery shifts the entire conversation. We are no longer talking about hauling every single bolt from Florida or India on expensive rockets that burn tons of fuel just to fight Earth's gravity. Instead, the moon itself is providing the materials for us to stay. It is a total paradigm shift. We are moving from being visitors to becoming residents. Along with these heavy hitters, the rover detected magnesium, silicon, and manganese, completing a mineral cocktail that makes an engineer's eyes shine. Every one of these elements serves a specific purpose in the machinery of space colonization. Silicon, for instance, is the foundation of our computer chips and solar panels. If we can extract silicon from the lunar dust, we could eventually cover the moon in solar panels to generate infinite energy. It is mind-blowing to think that all of this has been waiting in silence for 4 billion years, just for a rover the size of a suitcase to finally come and take a look. Despite all this mineral wealth, one element stands above the rest, the one every nation is hunting for: water. But do not imagine rivers or lakes on the moon. Water is a ghost hiding as ice in the depths of craters, where the sun never shines. These are the permanently shadowed regions, the coldest spots we have ever discovered, and Chandrayaan-3 went exactly there. Why are we so obsessed? Because water is the liquid gold of space. If you have water, you have life, not just to drink, but to breathe and to move. By splitting water molecules, we get oxygen for astronauts and hydrogen, the most powerful rocket fuel known to man. If we build a hydrogen gas station on the moon, a trip to Mars becomes much easier. We would no longer need to carry heavy fuel from Earth. We could just fill the tank with processed lunar water and leap into the rest of the solar system. This is why the confirmation of water ice at the South Pole is the defining discovery of our era. The Pragyan rover and the Vikram lander worked together to sense the moisture and hydroxyl groups that prove this water is not just a theory, but a reality right beneath our feet. It is thrilling to think that these eternal shadows, once feared as dead places, are actually the fuel depots that will make us a multiplanetary species. This ice is a time capsule, likely brought by comets and asteroids eons ago when Earth was just being born. Studying it is like reading the secret diary of the solar system. Every discovery by Pragyan is a reminder that we can live in other worlds, because India dared to look where others would not. The precision with which these elements were detected is what truly leaves the global community of experts in complete awe. This was not a vague report or a hopeful guess. It was a definitive presentation of data. India provided the world with the specific spectra and the undeniable proof that our neighbor is a chemical goldmine. One of the most breathtaking revelations from this data is the high concentration of calcium and magnesium found within the lunar soil. To a casual observer, these might just be names on a periodic table, but to those looking toward the future, they represent the dawn of lunar agriculture. Imagine, if you will, the scene 50 years from today. We could see massive, transparent domes rising from the surface of the lunar South Pole. Inside these controlled environments, using the very soil processed by our machines and the water harvested from the depths of nearby craters, we could be cultivating crops like potatoes or lettuce. What once seemed like the fever dream of a science fiction novelist has now been grounded in chemical reality. The literal building blocks needed to grow food on another world have been found waiting for us in the gray dust. The strategic importance of these findings extends far beyond the dinner table. The titanium detected by the Pragyan rover is a game-changer for human health and high-tech manufacturing. On Earth, we use this rare and expensive metal for everything from advanced spacecraft to medical prosthetics and precision tools. Having a direct source of titanium on the moon provides a strategic advantage that is impossible to ignore as we plan our permanent presence there. This mission has honestly served as a profound lesson in humility for every spacefaring nation on our planet. For decades, many of us believed we knew the moon inside and out because of the Apollo missions of the past. But the truth is, we were only scratching the surface, and we were only looking at one side. The South Pole is an entirely different world with a completely different story to tell. While it is a much harsher and more difficult terrain to navigate, it is also infinitely more generous in the resources it offers to those brave enough to reach it. Sulfur, iron, aluminum, and water are no longer just scientific curiosities. They are the four pillars upon which the first lunar city will be constructed. This vision began because one nation had the foresight to send a robot into a land where the sun never shines so that we could all see our future with more clarity. It is truly incredible how a handful of chemical elements that we take for granted here on Earth become the vital keys to preventing human extinction and allowing our species to continue exploring the vast unknown. Every single centimeter that the Pragyan rover moved forward was a step across the greatest treasure we have ever found in the heavens. This treasure does not glitter like gold, but it is worth far more because it grants us the permission to keep dreaming of the stars. Lunar geology has officially shifted from being a niche subject for a few scientists in a lab to becoming the roadmap for the next great human migration. We are only just beginning to grasp the true magnitude of what lies beneath that mysterious gray surface. If this is what we discovered in just the first few days of exploration, imagine the secrets that will be revealed when we have permanent bases excavating and analyzing every corner of that soil. The moon is no longer just a white light that guides us through the night. It is now our next home. And for the first time in history, we finally know exactly what the walls of that home are made of. If you thought that finding water and sulfur was the peak of this journey, prepare yourself, because what comes next is truly mind-bending. It is one thing to map the chemistry of the moon, but it is another thing entirely to understand how it feels, how it breathes, and how it reacts when we reach beneath its surface. The Chandrayaan-3 mission performed a series of experiments that left the global scientific community scratching their heads and frantically reevaluating their physics textbooks. This part of the mission was designed to listen to the silent world and feel the pulse of a place we once thought was a dead fossil. The first of these revelations involves something we all understand perfectly here on Earth: heat.
It's beautiful, isn't it?
However, on the lunar surface, heat does not behave according to the simple rules we were taught in high school. To investigate this, the Vikram module was equipped with a highly sophisticated thermal probe known as CHASTE. Imagine a very delicate, high-tech needle designed to be driven deep into the lunar soil to measure exactly what is happening beneath the dust. The scientists expected to see a logical, gradual transition in temperature as the probe went deeper into the ground. Instead, they were met with a thermal shock that no one saw coming. Oh, on the surface, where the sun strikes the ground even at an angle in the South Pole, the temperature was measured at approximately 50 degrees Celsius. For context, that is a pleasant, intense heat, similar to a scorching summer day in a northern desert city. But here is where the story turns into something out of a science fiction movie. When the scientists pushed the probe just 8 to 10 centimeters into the ground, a distance shorter than the length of a common cell phone, the temperature did not just drop. It plummeted in a way that defies terrestrial logic. At that tiny depth, the thermometer recorded a staggering 10 degrees below zero. In a space no wider than the palm of your hand, the temperature fell by 60 degrees. This is a radical thermal differential that simply does not exist in any natural environment on Earth in such a compressed space. It is as if you were standing on a hot stove, but your feet, buried just an inch into the sand, were simultaneously freezing inside an ice chest. This discovery is far more than a curious statistic. It is a profound revelation about the nature of the lunar regolith. What this data tells us is that lunar dust is a thermal insulator more powerful than almost anything we have ever manufactured in a laboratory. It is as if the moon is wrapped in a high-tech thermal blanket that prevents the sun's heat from penetrating even a fraction of an inch into the subsoil. For those of us dreaming of a future where humans live on the moon, this is the best news of the century. It means that if we build our future lunar bases slightly underground, or simply cover our modules with a thin layer of this native dust, we will not need to spend millions of dollars on incredibly complex heating and cooling systems. The moon itself is providing the perfect insulation to keep us at a stable, livable temperature. By simply scratching the surface, we can find a safe haven from the brutal, extreme swings of the lunar climate. This natural solution was hidden in plain sight for billions of years, just waiting for a probe and the curiosity of the Indian Space Agency to uncover it. But the mission did not stop at feeling the heat. It also sent an ear to the moon. This instrument, called ILSA, is a state-of-the-art seismograph designed to detect even the faintest vibration, something as light as the breath of an insect. During the days the Pragyan rover explored the area, ILSA listened to everything. It recorded the vibrations of the rover's wheels, which sounded like the steps of a giant on glass to such a sensitive device. However, there was a moment when the rover stood perfectly still and everything was in absolute silence. Suddenly, the instrument registered a natural seismic event. Yes, the moon moved on its own. This discovery gives us goosebumps because it reopens a debate that has no final answer. How alive is the moon on the inside? For a long time, we were told the moon was a dead rock, a frozen fossil with no internal activity. But this small moonquake suggests we might have been wrong. It is possible the moon still holds some heat in its core, or perhaps it is shrinking as it cools, like a grape turning into a raisin, causing the crust to crack and vibrate. There is also the possibility that the tidal forces from Earth are tugging on the moon, causing these tremors. Whatever the cause, detecting a natural seismic event in the South Pole is pure gold for understanding the internal structure of our satellite. We cannot build permanent cities or bases without knowing if the ground beneath us is going to move. We need to know where the faults are, how strong the moonquakes are, and how often they occur. India has just given us the first map of activity for a zone that had never been heard before. When you put all this together, the importance is staggering. On one hand, we have soil that protects us from extreme heat and cold, and on the other, we have a world that still has secrets in its depths and a moving, changing internal chemistry. This changes everything about how we see space exploration. It is no longer about surviving an inhospitable place. It is about understanding the environment to use it to our advantage. The mission of Chandrayaan 3 has served as a profound lesson in humility for every major space power on our planet. While space agencies like NASA or the Russian program operate with massive financial backing, the Indian Space Research Organization achieved a surgical landing and a world-class laboratory setup with a budget that, by comparison, is almost like pocket change. It is a testament to the sheer brilliance of the engineers at ISRO, who operated with the precision of a surgeon, proving that vision and persistence are just as valuable as billions of dollars. Every single byte of data sent back by the Pragyan rover was another piece of a puzzle that humanity has been trying to solve for centuries. When we step back and look at the bigger picture, all these discoveries begin to click together like the gears of a clock. We now understand why that precious water ice can survive in those deep, dark craters. If the lunar soil is such a poor conductor of heat that the temperature can drop 60 degrees in just a few inches, then the ice in those shadows is essentially sitting inside a natural refrigerator that never turns off. This realization changes everything. The moon is no longer just a barren rock. It is a giant safe that has been guarding the history of our solar system and the resources for our future. India did not just land a rover, they found the combination to the lock. What follows this moment is even more exhilarating for the rest of humanity because of the data collected on temperature and seismic activity. Every future mission, whether it is flown by Americans, Chinese, or private companies, will begin with a massive advantage. We now know for a fact that we do not need to haul heavy and expensive insulation materials from Earth because the lunar regolith can do the dirty work for us. We know to be cautious of the ground vibrations and to study the internal movements of the moon more closely. Most importantly, we have learned that the moon is not the monotonous, boring place it appears to be through a cheap telescope. It is a complex world with its own personality, inviting us to step inside, provided we follow its rules. Sometimes we forget how incredible it is to be alive right now. We have moved past being simple observers of the night sky. We have become the protagonists in the conquest of space. What the India mission found in the lunar dust is not just a collection of rocks and temperature graphs. It is
The
the
vessel is
ultimate
approaching the
confirmation
final
that when
descent
human
phase.
beings set
Monitor
aside
the
their
telemetry
limitations and
closely.
commit to a goal,
Telemetry is
they can
nominal,
reach the
Commander.
impossible.
They are clear
The
for
lunar
landing.
South Pole is no longer a blind spot on our maps. It now has a name, a recorded temperature, a chemical signature, and we even know the sound of its heartbeat. This mission leaves us with one unmistakable truth. The future of our species is not found in a distant, unreachable star, but right here on our constant companion. The moon is waiting for us with open arms, filled with water to drink, fuel to travel, and minerals to build our new home. Chandrayaan 3 did more than just land in the dirt. It landed us in a new era for humanity. To think that all of this started with a small rover rolling through the gray dust, firing lasers and listening to the pulse of a world we once thought was dead. The moon is more alive than ever. And thanks to these discoveries, we now know that we can be alive up there too. It is only a matter of time before those 50 degrees on the surface and the 10 below zero in the subsoil become the backyard of our next home. The adventure is truly just beginning, and we are lucky to be here as history is written in real time.